Hello my dear students, welcome back. Hope you all are fit and fine. This is the second video of the chapter Surface Chemistry. So students, without wasting any time, I will start with the topic adsorption isotherms. So students, what is adsorption isotherm? In simple language, I will say the variation in the amount of gas adsorbed by adsorbent with pressure at constant temperature can be expressed by means of a curve that is termed as adsorption isotherm. That curve is called adsorption isotherm. First, I'll talk about Freundlich adsorption isotherm. Well, students, Freundlich in 1909 gave an empirical relationship between the quantity of gas adsorbed by unit mass of solid adsorbent and pressure at a particular temperature. And the relationship can be expressed by the equation, and equation is x upon m is equals to k p to the power 1 by n, where n is greater than 1. And students, x is the mass of gas adsorbed on mass m of the adsorbent at pressure p. K and n are constants which depend on the nature of the adsorbent and the gas at a particular temperature. So students, the relationship is generally represented in the form of a curve where mass of the gas adsorbed per gram of the adsorbent is plotted against pressure. These curves indicate that at a fixed pressure there is a decrease in physical adsorption with increase in temperature. These curves always seem to approach saturation at high pressure. Students, when we will take logarithm on both sides of this equation, the equation would be like this: log x upon m is equals to log k plus 1 by n log p. One very interesting thing is the validity of Freundlich isotherm can be verified. How? It can be verified by plotting log x by m on y-axis and log p on x-axis. And students, if it comes to be a straight line, the Freundlich isotherm is valid, otherwise not. And the slope of the straight line gives a value of 1 by n. And the intercept on y-axis gives a value of log k. So students, Freundlich isotherm explains the behavior of adsorption in an appropriate manner. The factor 1 by n can have values between 0 and 1, and the most probable range is 0.1 to 0.5. This equation holds good over a limited range of pressure. Now, if I'll talk about adsorption from solution phase. So students, solids can adsorb solutes from solution also. Example, when solution of acetic acid in water is shaken with charcoal, then concentration of acid decreases due to adsorption of acid by charcoal. Also students, litmus solution becomes colorless when shaken with charcoal. So students, what observations we have made? Let's discuss the observations of adsorption from solution phase. First, adsorption decreases with increase in temperature. Second, adsorption depends on concentration of solute in solution. Third, adsorption increases with increase of surface area of adsorbent. Now we will talk about LANGMUIR adsorption isotherm. It explains mainly chemisorption, whereas Freundlich isotherm mainly explain physisorption. Let's study the postulates of LANGMUIR adsorption isotherm on which it is based. First is, the layer of the adsorbed gases is only one molecule thick, that is, it is unimolecular layer in nature. Adsorption involves two opposite processes, that is, condensation of gas molecules and evaporation of these molecules. Next, the rate of condensation of a gas is proportional to unoccupied surface of adsorbent, while that of evaporation to its covered surface. So adsorption can be given by this expression: x upon m is equals to ap upon 1 plus bp, where x is mass of gas in grams, m is mass of adsorbent in grams, p is pressure, a and b are LANGMUIR parameters. Students, let's discuss about the validity of LANGMUIR adsorption isotherm. At moderate pressure, X upon m is equals to AP upon 1 plus BP. At low pressure, BP is very less than 1. It means X upon m is equals to AP. That is, X upon m is directly proportional to P. And when we will talk about at high pressure, then BP is very greater than 1. It means X upon m is equals to AP upon BP. P will be cancelled from numerator and denominator. It will be A upon B, that is constant. Since A and B are constant, hence graph between P upon X upon m and P should be straight line, and slope is equals to B upon A and intercept is equals to 1 upon A. Now we will study the application of adsorption. Students, the phenomenon of adsorption finds a large number of applications. A few important applications I will discuss with you. First is removal of unwanted gases or vapors. Students, many times poisonous vapors are present in air. These can be adsorbed by suitable adsorbent, like in fermentation industry. The excess of carbon dioxide can make the product unpalatable, which is removed by adsorption on charcoal. Second is removal of coloring matter. Like in the production of sugar, vinegar, etc., there are a number of coloring impurities. These are removed by adsorbents like charcoal, etc. Third one is creation of high vacuum. Students, charcoal adsorbs all gases at low temperature. Thus, if a vessel is first evacuated by conventional techniques and then connected to charcoal at low temperature, the residual gases will be adsorbed by it and ultra high vacuum in the vessel will be obtained. It's really very interesting. Fourth one is catalysis. In heterogeneous catalysis, adsorption of reactants and desorption of products are very important processes. If I'll talk about application of adsorption in medicine, so students, many drugs are adsorbed by the various body tissues. Their effectiveness can be controlled by their selective adsorption. Now, if I'll talk about lubrication, we know that graphite acts as a lubricant due to adsorption of gases. At high altitudes, it loses its lubricating properties because the pressure of gases is very much reduced, leading to the removal of adsorbed gases from the surface of graphite. Now, in chromatographic analysis, all types of chromatographic techniques are based upon selective adsorption of different types of substances on a given adsorbent. Now, we will study catalysis. Students, when KClO3 is heated strongly, it decomposes to give O2. The decomposition takes place at high temperature like 653 to 873 Kelvin. However, when a small amount of MnO2 is added, the decomposition not only becomes faster but takes place at much lower temperature, that is in the range of 473 to 633 Kelvin. And very interesting thing is that the added MnO2, manganese dioxide, remains unchanged with respect to its mass and composition. So students, in the similar manner, the rates of number of chemical reactions can be altered by the mere presence of foreign substance. So my dear students, catalyst is a substance which can change the speed of chemical reaction without itself undergoing any change in mass and chemical composition at the end of reaction, and the phenomenon is called catalysis. Students, there are two terms. One is promoters and second one is poisons. So promoters are the substances that enhance the activity of catalyst, while poison decreases the activity of catalyst. For example, in Haber's process for manufacture of ammonia, molybdenum acts as a promoter for iron, which is used as a catalyst. And arsenic and carbon monoxide are the substances which can act as catalytic poisons. Students, catalysts can be broadly divided into two groups: homogeneous catalysis and heterogeneous catalysis. When the reactants and catalyst are in same phase, that is liquid or gas, the process is said to be homogeneous catalysis. For example, in this reaction, reactants are in gas phase, products are in gas phase, and catalyst is also in the same phase, that is gas. But when reactants and catalyst are in different phases, the process is called heterogeneous catalysis. For example, in this reaction, reactants are gases, products are gases, but catalyst is in solid phase. So this is the example of heterogeneous catalysis. Now students, we will study the adsorption theory of heterogeneous catalysis. According to old adsorption theory of catalysis, reactants in gaseous state or in solutions are adsorbed on the surface of solid catalyst. Due to this, the concentration of reactant on the surface increases and rate of reaction increases. As adsorption being exothermic process, the heat of adsorption is utilized in enhancing the rate of reaction. But students, the modern adsorption theory is a combination of intermediate compound formation theory and old adsorption theory, and the mechanism involves 5 steps. In first step, there is diffusion of reactant to the surface of catalyst. In step 2, there is adsorption of reactant molecules on the surface of catalyst. In step 3, there is occurrence of chemical reaction on the catalyst surface through formation of an intermediate. In step 4, there is desorption of reaction products from the catalyst surface, and so making the surface available again for more reaction to occur. In step 5, there is diffusion of reaction products away from the catalyst surface. The surface of catalyst, unlike the inner part of the bulk, has free valences which provide the seat for chemical forces of attraction. So students, this theory explains why the catalyst remains unchanged in mass and chemical composition at the end of reaction and effective even in small quantities. Now we will discuss the important features of solid catalysts. First one is activity. By activity of catalyst, we mean its capacity to increase the speed of chemical reaction. The activity depends on the strength of chemisorption. The adsorption should be reasonably strong, but not so strong that the adsorbed molecules become immobile and no space is available for other reactants to get adsorbed. Next one is selectivity. By selectivity of catalyst, we mean its ability to direct the reaction to form particular products excluding others. For example, in this reaction, nickel is catalyst. So a given substance can act as catalyst only in particular reaction, not for all the reactions. Now we will study the shape selective catalysis by zeolites. Students, the catalytic reaction that depends upon the pore structure of the catalyst and size of reactants and product molecules is called shape selective catalysis. And students, zeolites are a good shape selective catalyst because they have honeycomb-like structures. Zeolites are microporous aluminosilicates with three-dimensional network of silicate in which some silicon atoms are replaced by aluminium. The size of pores varies from 260 picometer to 740 picometer. Thus, only those molecules can be adsorbed in these pores whose size is small enough to enter these cavities and also leave easily. It will not adsorb those molecules which are too big to enter. Well, zeolites are being very widely used as catalyst in petrochemical industries for cracking of hydrocarbons and isomerization. An important zeolite catalyst used in petroleum industry is ZSM5, zeolite of sieve molecular porosity 5. It converts alcohol directly into gasoline, that is petrol, by dehydrating them to give a mixture of hydrocarbons. Next is enzyme catalysis. Enzyme is a biochemical catalyst and the biological reactions are catalyzed by enzyme catalyst. Students, enzymes are complex nitrogenous compounds which are produced by living plants and animals having high molecular mass ranging from 15,000 to 10 lakh gram per mole. Enzyme forms colloidal solution in water. If we want to convert maltose into glucose, enzyme is maltase. These are some more examples of enzymes. Now we will study the characteristics of enzyme catalysis. First one is each enzyme catalyzes only one reaction, so highly specific in nature. Second is enzymes are highly efficient catalysts. One molecule of an enzyme may transform 1 million molecules of the reactant per minute. The optimum temperature range for enzymatic activity is 298 to 310 Kelvin, whereas optimum pH range is 5 to 7. Next is the enzymatic activity is increased in the presence of certain substances known as coenzymes. Activators are generally metallions like Na positive, Mn2 positive, CO2 positive, Cu2 positive, etc. These metallions are weakly bonded to enzyme molecules and increase their catalytic activity. For example, enzyme amylase in the presence of sodium chloride, which provides Na positive ion, shows a very high catalytic activity. Last characteristic is the activity of enzyme is slowed down in the presence of certain substances called inhibitor or poison. Inhibitors interact with the active functional groups, thereby reducing or completely destroying the catalytic activity of enzymes. The use of many drugs is on account of their action as enzyme inhibitors in our body. Next, we will study the mechanism of enzyme catalysis. The most accepted mechanism of enzyme catalyst reaction is known as lock and key mechanism. There are number of cavities present on the surface of colloidal particles of enzymes having characteristic shape and possess active groups such as NH2, COOH, SHOH, etc. The molecules of reactants, that is substrate, which have complementary shape, fit into these cavities just like a key fits into a lock. On account of the presence of active groups, an activated complex is formed which then decomposes to yield the products. So, the enzyme catalyst reactions may be considered to proceed in two steps. In step 1, there is binding of enzyme to substrate to form an activated complex. And in step 2, there is decomposition of activated complex to form product. Now, these are some questions related to the topic. Hope you have enjoyed this video so much. Thank you so much for watching this video. Goodbye.